Numbers 17 through 20 are all very similar in that we are trying to find two things. Where is the particle? So we need to know where it started, and then we need to know the change in the position, and then the total distance traveled. So where is it at the end of the trip, and then the total distance traveled. So I need to find the area under the curve here, velocity on the vertical and time in seconds along the horizontal. So if I just create four triangles here, each one of these triangles has a height of 2 and a width of 1. So each one of these has an area of 1. So in number 17 for part A, we know that the original position was 2, and then the displacement was 4, so the position would be 6. Now the total distance traveled would be 4. In number 18, the area above the curve and the area below the curve is 2 above and 2 below, so that means that the position is still going to be at 2. Now the total distance traveled would be 4. In 19, if I break this up into areas, this has a height of 2 and a width of 1. So even though we consider this to be negative, I'm going to write it as 1 for now. And this would be 1, and this would be 2. And then this triangle here would be 2. And then this triangle inside here from 5 to 7 and then to 6, that would be an area of 1. So now I need to find two things. I need to find the position, and if it starts at 2, okay, if it starts at 2, then this negative 1 and that positive 1 would cancel out. We've got 2 here and 2 here, that's 4. And then take away this 1. So we have these canceling each other. Then we have 4. And then minus 1. So if we take 3 to what we had originally, then its new position would be 5. However, the total distance traveled is the absolute value, which would be 1, 2, 3, 4, 5, 6, and then 7. Now for 20, this one's a little bit more complicated, but you notice that this has a height of 3 and a base of 2. This area is going to be 3 here. Then if I break this up into sections, this is 1 by 3. So this is 1.5. This is 1.5. And then this will be 3. Here we have a base of 3 and a height of 3. So that has an area of 4.5. So now if we start with our original position, which is 2, then what we have here is, this is 3 times 3, so this is an area here of 9. I was cutting it in half like all the triangles. So this has an area of 9. And what we have then is this 3 cancels with those 3. The 1.5 here, 1.5 there, and this positive 3. And then we have the 9 here below the x-axis, so consider that to be negative 9, plus the 4.5, so we would have 2 originally, minus 9 plus 4.5, and that would give us negative 2.5. So the position would be negative 2.5. And then when we want to get the total distance traveled, then we're just going to take the absolute value of all of these. So it would be 3 plus 1.5, 1.5, that's going to be a 3, plus this 9, plus the 4.5. And so what we end up getting then is 19.5. So the total distance traveled would be 19.5.